Hey, in this lesson, we're going to talk about absolute value inequalities. And we've already done absolute value equations. And if you remember an absolute value equation, when the original equation had an absolute value symbol, you always had two equations to solve, and there would be two numbers that would be solutions. Well, for an absolute value inequality, it's very similar. You're going to have two inequalities to solve. And when you have two inequalities, that's what's called a compound inequality. And so you have two possibilities because either your original inequality has a less than sign or it has a greater than sign. When the original inequality symbol is a greater than sign, that ends up with the connecting word or. And if your original inequality symbol is a less than sign, then you would have the connecting word and. So it depends on what the original one is. Now I have, I think, 4 examples of greater than signs and 4 examples with less than signs, and I'll try and show you why we use or with the greater than signs and why we use and with the less than signs. So here's the first example. It says the absolute value of x is greater than 5. And this is a simple example where inside the absolute value symbol is just the letter x. That's all that there is. So if we do a quick little sketch here of what a number line would look like. Now remember there are two numbers that have an absolute value of 5. You have the number 5 and you have the number -5. Well, you're looking for numbers whose absolute value is actually greater than 5. Those would be the numbers to the right of +5, but they'd be the numbers to the left of -5. Things like -6, -7, those numbers, when you take their absolute value, the absolute value of -6 is 6, and that's bigger than 5. So we end up with our two equations, and we can get them from right here and here. Two inequalities, rather. Your first inequality that you would write comes from the 5. And it's really right there with the 5 when you look. X has to be greater than 5. And then the second one comes with the -5. When you look at that, it's telling you that x has to be less than -5. And so your answer, you're going to connect it with the word or. X is greater than 5 or x is less than -5. There really was no work involved to solve either one of those inequalities. But you have your compound inequality connected by the word or. And that's because the original inequality had a greater than sign. On the second one, I'm just going to draw a quick number line again. Put the numbers that have an absolute value of 2, +2 and -2. This one, it says we need it to be greater than or equal to 2. So again, it's greater than. Numbers that have an absolute value of greater than 2 would be to the right of +2 and to the left of -2. And so you're going to get two inequalities. And again, each of these arrows is kind of describing to you your inequalities that you're going to need to solve. The first one that I numbered a 1 has an arrow pointing to the right of 2. So the stuff in the absolute value symbol, x -7, it has to be either greater than or equal to 2. But then our second inequality that we're going to solve has the arrow pointing to the left of -2. And going to the left is a less than sign. So the stuff inside the absolute value symbol, x -7, is less than or equal to the number -2. And now I just solve both of these inequality symbols. Remember, my connecting word is or. And you solve both of them the same way. You'll add 7 to both sides. So on this one, you get x is greater than or equal to 9. My connecting word or. And on this one, when you add 7, you get that x is less than or equal to 5. And there's my solution. Compound inequality connected with the word or. Hey, on the next page, we just keep doing the same thing. And I'm making the stuff inside the absolute value symbol just a little bit more difficult. Here, we want greater than 25. So here are the two numbers that have absolute values that are 25 and -5. numbers that have an absolute value greater would be to the right of 25. They'd be to the left of negative 25. So I'll get two inequalities again. I'll number the arrows that are going to help me write the inequalities, or the inequalities I need to solve. The first one would be 4x plus 3. That's the stuff inside the absolute value symbol. Right, where I have the arrow number 1 is pointing to the right of 25. So that's greater than 25. My connecting word again is or. And now my second inequality is the arrow pointing left of negative 25. And so when I do that, I have the stuff inside the absolute value symbol. The left would be less than, and then the negative 25, because that's the number where that arrow is. Both inequalities you solve the same way. You subtract 3 first. You get that 4x is greater than 22. When you solve that, you get that x is greater than 5.5. Connecting word or. On this one, when you subtract 3, you get that 4x is less than negative 28. Therefore, x is less than negative 7. There's my compound inequality with the connecting word or. Now, on this last one, this is another one that we did with the equations similar, how we have this plus 7. The first thing you need to do is subtract 7 from both sides. And that's going to leave you with the absolute value of 8x minus 3 is greater than 38. And now it's just like number 3 that we just did. So if I sketch my number line quick here, now it's 38, but the absolute value has to be greater than. That would be 38, negative 38 again. Because it's greater than, we want the numbers to the right of 38 or to the left of negative 38. Now number 1 and 2 again. And then as I put my two inequalities to solve, one of them is going to be 8x minus 3. The number 1 is pointing right, so greater than, and it's by the positive 38. Connecting word or. And my second inequality 8x minus 3, and this time pointing left, and it's by the negative. Both of them, you add 3 first, so 8x is greater than 41. Therefore, x is greater than 5 and 1/8. Connecting word or. When you add 3 over here, you get that 8x is less than negative 35. Divide by 8, you get that x is less than negative 4 and 3/8. There's your compound inequality connected by the word or. Now, each of those graphs that I just quickly sketched in green, you can see that each one has one arrow pointing one direction and an arrow pointing the other direction. Now, if you remember, whenever we would graph inequalities, when it looks like that, those were always or inequalities. Okay, and that hopefully shows a little bit why it's or. Okay, now, the next 4 we'll try and do quick. These are all going to be connected by the word and. I start off again with a simple inequality where the only thing in the inequality symbol is x. So here we have 4. The other number that has an absolute value of negative 4. Okay, both of those numbers, the absolute value is 4. This time we want numbers whose absolute value is less than 4. Now those would be to the left of positive 4, but they'd be to the right of negative 4. And so we're still going to get 2 inequalities to solve. Okay, the first inequality that I have to solve is just going to be x, and now that by the number 1, the arrow is going left, so is less than 4. Okay, my connecting word this time is going to be and. My second inequality, which is an arrow pointing to the right, so that's going to be x is greater than, and it's using the negative 4. And so we would have x is greater than negative 4, and x is less than 4. And that would be this. That can also be written, remember, as negative 4 less than sign x less than sign 4. Okay, that's the same thing. And remember that and inequalities can be written this way. Now we just go through each one of these. When I sketch a quick graph here, the number is 9, so these are the two numbers whose absolute value is 9. We want it to be less than or equal to, so it's to the left of the positive 9, to the right of the negative 9. And these will be my two inequalities to solve. This time my inequality is a little bit tougher to solve. I have x plus 3 in the absolute value symbols. Number 1 has an arrow pointing left, less than or equal, and it's by the number 9. Our connecting word is and again. Second inequality is just going to be the x plus 3, and this time greater than or equal to negative 9. Both of these you solve by subtracting 3, so x is less than or equal to 6, and x is greater than or equal to negative 12. So there's one inequality. If I choose to put those together, I would have negative 12 less than or equal to x, less than or equal to 6. If you write it without the word and, is one long inequality. Okay, the last two. Okay, and number 7. Okay, if we sketch our number line again, we have 17 this time. It's 17, negative 17. Absolute values that are less than that would be to the left of 17, okay, and would be to the right of negative 17. So those are going to be our two inequalities that come from these two arrows. The first inequality is going to be 2x minus 5. Okay, and number 1 has an arrow pointing left, less than, and it's beside the number 17. I forgot my connecting word. This time is and. The arrows are pointing toward each other, so that's and. And then we have 2x minus 5, and it's an arrow pointing to the right, and it's by the number negative 17. So we add 5 first. 2x is less than 22. And when you divide by 2, you get that x is less than 11. And here, when you add 5, you get 2x is greater than negative 12. Therefore, x is greater than negative 6. There's your compound inequality with the word and. If you write it out with just 1, you get negative 6 less than sine x less than sine 11. And on the last one, we have to, in this case, add 8 first on both sides. Get 2 minus 3x, absolute value. A is less than 29. Quick sketch of what this would look like. I'll put this sketch right here because I don't have space. This time it's 29. So we have 29 and negative 29. Absolute values less than that would be to the left of 29, to the right of negative 29. So those would be our two inequalities. Okay, the first one would be 2 minus 3x. Okay, and number 1 is the arrow going left, so less than 29. Connect with the word and. Second inequality, squeeze it in here. 2 minus 3x. Okay, this one, the arrow for number 2 is pointing right, so greater than, and it's by the negative 29. And now on this, solving the inequality is a little bit tougher. You have to subtract 2, so you get negative 3x is less than 27. And when you divide by negative 3, you actually have to switch the inequality. So you get that x is greater than negative 9. And now on this one, you subtract your 2, you get negative 3x is greater than negative 31. And when you divide by negative 3, switch the inequality, and you get 10 and 1/3. Again, we have our connector and. And if you put it all together as 1, you have negative 9 less than x less than 10 and 1/3. So absolute value inequalities result in compound inequality. If the original inequality symbol is a less than, you're connected by the word and. If the original inequality is greater than, you're connected by the word or.